Okay, let's take a look at section 2.5, solving absolute value sentences graphically. So we're going to take a look at absolute values. We're going to see a way to solve them simply using a number line. So what we want to think about is the fact that we've thought of absolute value already as the distance between a given coordinate and 0 on a number line. But what we can also say is that the distance between numbers a and b on the number line is absolute value of a minus b, or absolute value of b minus a. And notice that when we are representing the distance, we use a minus sign. Let's make sure that this makes sense in our mind for a second. So if we had a point on a number line that was at 7, another point that was at 3, and I wanted to know the distance between 7 and 3, I could simply subtract them, right? I would say, all right, just 7 minus 3, so the distance between them is 4. But I could also just say 3 minus 7, provided I put absolute value around it, and we still get 4. So really, if I just put absolute value around each of these, generically I could say that absolute value simply means distance between. So again, notice it could be a minus b or b minus a. You get the same answer. Let's keep this in the back of our mind for the next part. Example 1, solve x minus 4 inside of an absolute value equal to 3 graphically. Well, for this problem we have to say, well, x is now our point on the line, a, right? Remember before we said a minus b, that's what we were just saying? And this would be our distance right here, 3. So 3 is our distance and a minus b. Well, a is unknown, but b is clearly known. b is 4 in this case. So if we think about our number line for a second, we know that there's a point at 4 that we're talking about. And the other point is located, or it's called simply x. Well, if I want to know where x is, I know that x is somewhere out here, some distance away from 4. I don't know if it's on the right side, I don't know if it's on the left side, but I know it's some distance away from 4. It could be greater than 4 or it could be less than 4. But I do know that the distance here is 3. So there's going to be 3 units here, and there's going to be 3 units here, which means that this point must be 7. Simply 4 plus the distance away, 3, to give us 7. And this value over here must be 1. And that's simply 4 minus 3, giving me 1. So what I like to think about is this. Call 4, or the middle, your starting point, and call the gap that you go, which it would be 3 in this case, this gap right here, call this your deviation. Okay, deviation just means change. How much you deviate from the norm. So the starting point is always going to be represented by whatever quantity is here. Again, assuming that it is x minus some number. And the deviation is always going to come from whatever's on the right-hand side of the equation. So what would we say our solution for this is? Our solution is x equals 1 or x equals 7. Notice we could have solved this algebraically by setting x minus 4 equal to 3 and setting x minus 4 equal to negative 3. We can solve this problem algebraically by simply adding 4 to both sides. And take a look, the same exact solutions we got solving graphically. So again, we have a starting point and a deviation. Example 2 says solve absolute value of y plus 3 less than or equal to 5 using a graphical method. So again, we have to indicate our starting point and our deviation, and now we're going to notice that it's an absolute value less than some quantity, which if we remember from yesterday means this is going to be an and statement. Okay, it's going to be some distance away, less than 5 units. But the problem now is that I don't have a minus b in the right form. I have a plus b, it looks like. So I should rewrite this as the following. And now it's clear that this is a and this is b. So we start at negative 3. That's our starting point. And we deviate a value of 5 left and right. Deviating 5 to the right, we get to 2. Deviating 5 to the left, we get to negative 8. Now, a minute ago I mentioned that this is clearly an and statement because we have some variable quantity over here, and that variable quantity happens to be less than or equal to some distance away. So I know that it's going to be close to it. But if you didn't know if this was true, just test the point, please. Go ahead and test the point. So you could test any point. Test 0. 0 is somewhere in here, right? Zero's in here somewhere. So we know that we have clearly a closed circle here, and we have a closed circle here, and either it's going to be an AND statement where we highlight in between, or an OR statement where we highlight outward. Well, here let's go ahead and test the value 0. Testing 0 is 0 plus 3 is 3, less than 5? Yes, it is. So that means that this is correct. Test the value like, say, 3. 3 plus 3 is 6. 6 is not less than 5, so this is not a true region. And if you test a point like -9, -9 and 3 is -6. Absolute value of that gives us +6, and again, that's not less than 5. So this is not true either. So the only value that works are the values in between here. So that's what we shade. So our solution set for this problem looks like the following. Number 3 says absolute value of 7 minus 2r greater than 5. So right away we have to notice that the variable term is on the other side. So we really have like a minus b, but now b is the variable term. But remember a minute ago we said that a minus b or b minus a is the same thing if we look at them inside of the absolute value. So we really don't have to worry too much about this one because we could just switch the order. So we could start by doing this. And that's completely fine because again it's inside the absolute value, so it doesn't matter which way we subtract because it's inside the absolute value. So when inside absolute value, subtraction in itself becomes commutative, if you noticed. Next we'll see that we have this 2 coefficient in front of the r, but really we would like to have a 1 there. So let's go ahead and factor out a 2. Now if I do that, I should write it like the following. Take out a 2 in absolute value terms and multiply that by, we're left with r minus 3.5, and that's greater than 5. But again, the absolute value of 2 is simply 2, so I can technically drop the absolute value bars. But again, I want you to remember that you have to really put them out there initially, but again, you can drop the absolute value bars. Next, we divide by 2 on both sides. And we are in the form we would like to be in. Here's our starting point, here's our deviation. Start at 3.5, add 3.5 to that, giving you 6, subtract 3.5, giving you 1. Since this happens to be a greater than statement, it's going to be an or statement. Okay, because of this greater than symbol, that's indicating an or. And we know that they're open circles, so our solution set for this is going to be r less than 1 or r greater than 6. Example 4 says solve for x in terms of the other variables in the inequality. This looks confusing at first, but we have to identify this right away as our starting point. And this is going to be our deviation. So let's start at the point C. That's our starting point. It doesn't have to be a number. Let's deviate by a distance b. So if this distance here is b, then this really is just c plus b. And if this distance is b, then to get here, it's really c minus b. Well, this is a less than symbol here. It's a less than symbol. So what I can do is remember that less than means an and statement. So I'm actually just going to highlight in between these. And this is tough to test a point in. So you have to remember that this less than symbol up here really indicates an and statement. And therefore my solution set looks like the following. X starts from c minus b through x all the way through c plus b, not including the endpoints, open circle, or less than symbols. Your homework for this section is from 2.5 and a review problem from 2.3.